Every once in a while, a single idea comes along that doesn't just nudge things forward, it completely lights a fire under an entire field. In the world of AI, that moment came in 2017. It was a research paper that basically unleashed the kind of AI we're all seeing and using today. The paper was called "Attention is All You Need," and believe me, it changed absolutely everything.
So how do you even measure the impact of an idea like that? Well, one way is to see how many other big ideas it sparks. This paper, it's been cited by other scientists over 173,000 times. Just let that sink in. That doesn't just make it important, it makes it one of the most foundational scientific texts of this century. This is pretty much the rulebook for modern AI.
And here it is, "Attention is All You Need." The title, which is, a fun little nod to the Beatles, actually hides this incredibly bold claim. What these 8 researchers from Google were saying was that they'd found a single, super elegant mechanism that could crack one of the biggest problems AI had with understanding language.
So, what was this massive problem they were taking on? To really get why their breakthrough was such a big deal, we have to rewind the clock and look at how AI used to understand language. And it was all stuck behind this one major bottleneck. It had to do everything in order. Think about how you're reading a book. You go word by word, left to right, right? That's pretty much exactly how the older AI models, things like RNNs, worked. They processed text sequentially, one word at a time, trying to carry the meaning along with them every step of the way.
And this chart really lays it all out. The old models were stuck going word by word, which created this thing called an information bottleneck. It's like if you read a really, really long paragraph, by the time you get to the end, you've probably forgotten some of the details from the beginning. That's exactly what was happening to AI. It was slow, it was forgetful, and you just couldn't scale it up. The transformer idea was totally different. It asked, what if we could just look at the entire sentence, all at once?
And that brings us to the core breakthrough, the engine that made it possible for a model to see everything at the same time. It's this beautiful, powerful concept called self-attention. Self-attention is the secret sauce. It's a mechanism that lets every single word in a sentence look at every other word in that same sentence, all at the same time. It's like it's building this instant web of connections, figuring out on the fly which words are most important to which other words. So if you have a sentence like, "The robot picked up the ball because it was red," self-attention can instantly figure out that it refers to the ball. It doesn't matter how far apart they are. Just like that, the memory problem was solved.
Okay, so how does it work under the hood? Well, you can think of it like a little search engine inside the sentence. For every single word, it creates a query. The query is basically the word asking, hey, who else in this sentence is important to my meaning? At the same time, every other word holds up a key, which is kind of like a label or a tag that says, here's what I'm about. The first word then compares its query to all the other keys to find the best match. And when it finds a good match, it pulls in that word's value, which is its actual substance, its meaning. It does this for every word all at once. It's an incredible way to build a rich understanding of context.
And that was the real game changer. Because they got rid of that one word at a time process, the whole calculation could just happen in parallel. This was a perfect fit for modern GPUs, which are designed to do tons of calculations at once. All of a sudden, training these giant AI models became exponentially faster. It meant they could get much bigger and way more powerful than anyone thought possible. So, self-attention was this amazing new engine, right? But an engine needs a car built around it to actually go anywhere. And that complete package, the whole architecture, is what we now call the transformer. Now, while self-attention is definitely the star of the show, the paper introduced 2 other ideas that were just absolutely essential to making the whole thing work: multi-head attention and positional encoding. Okay, so if self-attention is like one person reading a sentence and connecting all the dots, multi-head attention is like having a whole panel of experts do it simultaneously. Each head is like a specialist. One might be looking at grammar, another might focus on who did what to whom, and a third might track abstract concepts. By having them all look at the sentence from different angles at the same time, the model gets this incredibly rich, multi-layered understanding of the text. But wait a second, this brings up a pretty big problem, doesn't it? If you're looking at all the words in a sentence at the exact same time, how do you know what order they came in? The sentence, "the dog chased the cat," means something totally different than "the cat chased the dog," even though the words are identical. So how does the model know the difference?
The solution is just so clever. It's called positional encoding. Before the model does anything else, it adds a little bit of information, a unique vector, to each word. This vector is generated using a mathematical trick with sine and cosine waves, and it basically acts like a timestamp or a coordinate. It doesn't change what the word means, but it gives the model a very clear signal about where that word is in the sequence: position 1, position 2, position 3, and so on.
So why use something as specific as sine and cosine waves? Well, we don't have to guess. The authors explain it right in the paper. They say they chose this method because these waves have a really consistent pattern, and they figured that would help the model handle sentences that were way, way longer than anything it saw during its training. It was a simple, elegant way to future-proof their own model.
So, you put all the pieces together. You've got self-attention, multi-head attention, and positional encoding, and boom, the transformer architecture is born. What happened next wasn't just progress, it was a straight-up explosion in the world of AI.
The timeline after this paper is just wild. It drops in 2017. A year later, just 1 year, Google releases BERT and OpenAI releases the very first GPT model. Both are built directly on the transformer. Then you fast forward to 2022 and ChatGPT, a direct descendant of this exact architecture, kicks off the massive generative AI boom that we're all living through right now. Literally every major AI language model you can think of today stands on the shoulders of this one paper.
And there's this incredible final chapter to the story. The 8 authors, who are now kind of legendary in the field, became so influential that every single one of them eventually left Google. They went on to found their own billion-dollar AI startups or take top jobs at other major companies. They basically fanned out and personally seeded the entire tech industry with the revolution they had started.
In the end, that audacious title proved to be true. For understanding language, it turns out attention really was the key that unlocked everything. So it leaves us with this huge lingering question. As we look to the future, what's going to be the next deceptively simple idea that turns out to be all you need for the next generation of AI?